Hello everyone and welcome to this new video. I'm happy to have you here on this new tutorial. So as mentioned in the thumbnail, we will fine-tune the Llama-3 8 billion model and Gemma-7 billion model on free Google Colab notebook. It's task-oriented fine-tuning. We will take a news article in English and we will generate an Arabic summary for it and also Arabic title. So it's like generation and summarization both at the same time. That's why the title is summarize and translate using large language models. So here you can find all the steps on my blog post. So let's start by the introduction. So we will take both models, Gemma-7b and Llama-3 8 billions, and we will work through these steps in order to fine-tune them on that task. First, we will start by dataset creation. I will show you how I created the dataset. It's publicly published, it's publicly available on Huggingface, and then how we create the prompt, because the prompt here contains an instruction. It's a fixed instruction since we are going to fine-tune on the same task. And finally, the model fine-tuning using Unsloth AI library. So thanks to Unsloth AI, we could fine-tune those relatively big models like 8 billion and 7 billions on free Google Colab. So let's start by the data preparation. I first took sample from the XLSAM dataset. Let me show it to you here. It contains variety of news article in different languages. So as you can see, there is the ID, URL, title, summary, and text. So what I did here, I kept the text, which is the news article. I translated the summary and the title to Arabic to generate our dataset. Okay, first sample selection, second translation. While keep the news article in English, we translated the summaries and the title into Arabic, and then the JSON representation. Okay, so let me show you our dataset. It's called English text Arabic summary. We have the news article in English, the summary in Arabic, the title in Arabic, and the summary plus title. It's a JSON representation with two keys, summary and title. So this, why I did that, I added this column in order to fine-tune the model. So I want the output or the generated output of the model to be on this format in order to parse it after that and to have well-structured output. So as I said, the dataset is available. It contains 1000 rows for training and 100 rows for testing. Let's go back to our blog. Okay, so the second part is the prompt. So for the prompt, we have system message, a fixed instruction, because we are fine-tuning on the same task. We are not fine-tuning for summarization and then for answering mathematical questions and translation. Our task is predefined, is to take the news article in English and generate both summary and title in Arabic. So the input is the news article and the response is the JSON representation I just showed you here. And this is the prompt. So there is the instruction. Below, an instruction that describes the task paired with an input that provides further context. Write the response that appropriately completes the request. So we have the instruction. That's the first component. Your task is to understand the provided text in English and generate a summary and a title for it in Arabic. The result should be formatted in JSON. Follow these steps. So I gave him the steps to follow: comprehension, summary generation, title generation, and output formatting. Then we will pass the inputs, which is we will loop on the news article as input, and the output corresponding to it should be that. That's pretty simple and straightforward. Then we will use the task-oriented fine-tuning. Obviously, that's what we are doing. We are using the Unsloth AI on a free Colab notebook, which will help us to process 2.2 times faster and reduce the VRAM usage by 80%, which is fascinating. This efficiency allows us to perform the fine-tuning on free Colab notebook, making the process accessible and cost effective. So you can read all of this stuff here. I will share the link in the description, and without further ado, let's jump directly and test our code. So first I prepared this notebook just for inference to show you what's the result of the model before fine-tuning it. So let's install the Unsloth from their GitHub repository. And then also we need to install the Xformers, TRL, which stands for Transformer Reinforcement Learning, PEFT, parameter efficient fine-tuning, Accelerate, and Bits and Bytes for quantization. I didn't change this name. I know that alpaca is related to the dataset alpaca, but I kept the name like that because it's related to the organization of the prompt, like instruction, input, response. Okay, then we will import fast language model from Unsloth. We can change those, but let's keep them like that. The max sequence length, dtype, loading 4 bits. We are not going to import this model, which the model I fine-tuned and I pushed to Huggingface. You can use it, but we are going to jump to this here. Unsloth LLAMA-3 8 billion bits and bytes, 4 bits quantized. We will import this model and we will inference it. So for the inference, all we need is to prepare an input. So for the input, it's here. Let's take new news article. So for example, let's go to Al Jazeera. Israel war on Gaza. May God be with our brothers in Gaza. So let's take a news article. For example, airstrikes continue. Okay, Israeli airstrikes continue across Gaza as truce talks struggle. So, okay, let's take, for example, here, this part, copy, and let's see what is it about. Okay, so that's our input. Let's wait for the model. And now by running this code, we will have the generated answer. Okay, so it starts from here. Okay, okay, so we can see that the response started by a JSON representation with the summary key, because as you remember, we stated that in the prompt. We said that we need formatted, the result should be formatted in JSON. And here the output formatting format the summary and title into a JSON object with the keys summary and title. Okay, so the model is capable of understanding that, but let us finish. So we can see that the summary is in English. It didn't translate it in Arabic. And also there is no title. Okay, there is no title. And the JSON representation is not complete. So it didn't finish by the brackets. Okay, so that's the model without fine-tuning. Now, I don't want to spoil, but let's see the result of our model after fine-tuning it. So we import this from my repository, the Llama-3, which is fine-tuned on this dataset. And we will use the same input. I created this parse response function to return only the summary and title in a Python dictionary, and let's call this function and let's generate. Okay, let's wait a minute, and good. So we have the summary. So the result is relatively good. The summary is short, but it's in Arabic and makes sense. The representation, as you can see here, it's parsable. The JSON representation is complete with the 2 keys we asked for, and that's perfect. So we can see the added value of the fine-tuning process we did. So without fine-tuning, it's not capable of generating Arabic content, and it's not capable of giving like a good JSON representation at the end. After fine-tuning, it contains all what we asked for. So let's jump to the fine-tuning Colab notebook. I'm not going to run this because it's going to crash my runtime, but we will start by importing the same as we imported in the inference. We import the Unsloth from their GitHub repository, Xformers, TRL, PEFT, Accelerate, Bits and Bytes. Then they have a list of models. We can try the Mistral, the Llama-3 billion, Instruct, or the Phi-3, the Mistral, and the Gemma-7b. Okay, we will try the Gemma-7b after that. It goes practically the same process. You just need to select one model to fine-tune, import that model, and in this part here we will add the LoRa adapters, so we only need to update under 10% of all parameters. And as you can see here, the Unsloth patch 32 layers with 32 QKV, which is query key values layers, and 32 MLP layers, O layers and MLP layers. For the data preparation, we have the same alpaca prompt that we used in the inference. Contains the instruction, the steps, input, output. Here's the formatting prompt function, which will create this, like for each input and response we have in the dataset, we will create this prompt. Then I'm going to import my dataset, which contains 1000 row. Here I needed to mention that I only took the rows with length under 1800, which are only 530 lines or rows of data. We didn't fine-tune on the whole dataset because otherwise it will surpass the maximum sequence length. Okay, so we do dataset map and we map it using the formatting prompt function. And then for the training, we are going to use the Huggingface TRL library, which stands for the Transformer Reinforcement Learning. And you can read more about it here. And we are only going to do 60 steps of training to speed things up. After that, we can see that on each step, the training loss is getting smaller until we reach on the step number 60, 0.93. And now for the inference, you are going to need an article, news article. You are going to pass it as an input for the tokenizer. And then you ask the model to generate the response. Basically, it's to complete the prompt. Since the model is pre-trained on something like that contains input and response, once you will give him something that stops here, he will generate the rest of it, respecting all those steps. So when we do the inference, we only give him this part, which is the prompt, with the input that contains the news article, and the model will continue the rest of it, which contains the response. So basically, this is how it works. Okay, so here we can get like the one response at a time, or we can also use the text streamer to generate the response in real time, like in ChatGPT. When you ask him, you don't wait for the answer one at a time. You will generate token per token, so we will see the streaming response. Okay, so we have the input and the response. This is not parsed yet, so you can see that it always ends with end of text token. The model uses this token to stop the generation, otherwise it will continue until the model reaches the max sequence length. Then after doing that, you can save it and push it to Huggingface. Let me show you. You will have it like that on your Huggingface. So for me, I pushed the Gemma-7 billion and the Llama-3. The model card is not finished yet. By the time you will watch this video, this will be changed, hopefully, with more instruction how to use it and do the inference with it. So also you can use the AutoPEFT model for causal LLM from the PEFT library, which we have used in our previous tutorials, but they said that you can use the Huggingface auto model for PEFT causal large language model. Only use this if you do not have Unsloth installed. It can be hopelessly slow since 4-bit models downloading is not supported, and Unsloth's inference is 2 times faster, so it's not recommended. All the code, guys, is presented here in this GitHub repository, generate and translate using LLMs. You will find 3 notebooks, the first for fine-tuning Gemma-7 billion, the second for the Llama-3-8 billion, and the third for the inference only. So let's go back to our blog. I didn't show you the result for the Gemma-7b, so you can go through this notebook by yourself to explore and see what Gemma-7b is capable of. But in my personal experience, let me go back. In my personal experience, after fine-tuning the Gemma-7b and the Llama-3 8 billion model, we observed that the Llama-3 model performed better in several key aspects. It consistently represented the output format as JSON, and also the Llama-3 provide more meaningful summaries and title that adhered to Arabic grammar. It respected the Arabic grammar better than the Gemma-7 billion. Okay, so I prepared this challenge for you guys. So I invite you to take this challenge to further explore and validate our findings. So using the test set we provided, which contains 100 rows, you can use this, evaluate better both models. You can use the blue score, rouge score, or even the Jacquard index or rapid fast to determine the performance of each model. So to do that, you can prepare the test set, generate outputs for both models, and at the end evaluate your output using one of these metrics between the generated output from each model and the ground truth. So the ground truth should be this column right here, which represents the summary plus title. Okay, so I hope you find this video and tutorial very informative. You can find all the other tutorials we did and the piece of code on my GitHub here. You can find other videos on my YouTube channel. I don't upload very much. I have like 3 videos right now, but I promise you I will upload more, hopefully. And also you can always contact me and connect with me on LinkedIn. Thank you very much and see you in the next video. Bye bye.